Hello everyone, Namaskar. My name is Gagan Kumar. Welcome to my channel Maths Guidance. This is going to be the second lecture of the topic polynomials, chapter 2. So far in lecture 1 we have understood the terms like constants, variables, and algebraic expressions, coefficients, number of terms of polynomials, and the degrees of polynomials. Okay, so in the second lecture we will understand the types of polynomials, according to the number of terms also, and according to the degrees also, and we will understand all of these things through questions and examples as we have practiced earlier also. So let us start the lecture 2, and I hope you are liking the video. Thank you. Let us start it. The types of polynomials. Types of polynomials. First one we will see according to various degrees. Okay. So what are the types of polymers according to various degrees? First of all, we have linear polynomial. Linear polynomial. So as the name suggests, the linear polynomial, a polynomial of degree 1. A polynomial of degree 1 is called a linear polynomial. A polynomial of degree 1 is called a linear polynomial. So all the polynomials having degree 1 are called linear polynomials. For example, you can write 5x plus 3, 17y plus 9. Okay, this will be polynomial in variable x, and this is polynomial in variable y. Okay, you can write both in xy, like 9x plus 5y plus 10. This will be a linear polynomial in variables x and y. Linear polynomial in variables both x and y. So this is very clear. A polynomial of degree 1 is called a linear polynomial. Okay, linear polynomial. So now let's come to second one. Second one is quadratic polynomial. Quadratic. So this type of polynomial will have degree 2. Okay, so the definition will be like this: a polynomial of degree 2 is called a quadratic polynomial. Okay, so let us write the examples. Like x square plus 5x minus 7. This will be a quadratic polynomial. The degree is 2. Highest power of variable x is 2. Okay, you can write more examples. Let us write in y, like 7y square plus 19y minus 5. Okay, you can write in more variables, like xy plus 5 xy plus 5. This will also be a polynomial of 2 degree, because the highest, the sum of the powers of variables is 1 plus 1 is 2. So this all of these are polynomials of degree 2, that is quadratic polynomials. Okay, so third one is cubic polynomial. Cubic polynomial. So this will be of degree 3. A polynomial of degree 3. A polynomial of degree 3 is called a cubic polynomial. Now you can write the example. Example you can write like 10x cube plus 5x square plus 7x plus 2. This will be a cubic polynomial in variable x. Cubic polynomial in variable x. Okay. Let us write one polynomial, cubic polynomial in degree x and y both. So like you can write 5x square y, 2 plus 1 3. Okay. 5x square y plus 7xy square, okay, minus 10. So here 2 plus 1 3, here 2 plus 1 3. So this will also be a cubic polynomial in variables x and y. Okay. So let us understand one more polynomial is biquadratic. This is biquadratic polynomial. This will be a polynomial of degree 4, a polynomial of degree 4, because bi means 2 and quadratic is of degree 2, so 2 to 4. So let us write the examples. Examples will be like x to the power 4 minus 5 minus 4x cube plus 2x square minus 7x plus 14. Okay, you can write more examples like 10x square y square plus xy cube minus y power 4 plus 10x, like this. So both will be polynomials of degree 4. So let's move forward. Now let us learn one important concept, that is general form of polynomials. So what do you mean by general form of polynomials? Let us understand one by one. First, polynomial of degree 1, that is linear polynomial. Let us understand with this linear polynomial. We write any linear polynomial like let's write 4x plus 5. You can also write 16y minus 9. You can write in variable z also, 5z plus 16. But when you notice, you will get to know that you cannot write more than 2 terms. You cannot write a linear polynomial having more than 2 terms. Okay. So a linear polynomial will have at most 2 terms. At most 2 terms means it will never have more than 2 terms. Okay, and the general form will be like this: ax plus b. The general form will be like this: ax plus b, where a and b are constants. Okay, and a is not equal to 0, because when you make a is equal to 0, then it will be a constant polynomial, because this x term will become 0. Okay, so ax plus b is the general form of polynomials, linear polynomial, where a and b are constants and a is not equal to 0. Similarly, you can write ay plus b. It's a linear form of polynomial in variable y. Linear polynomial. So a linear polynomial will have at most two terms, which we have understood through examples, and the general form will be ax plus b, where a and b are constants. Now let us understand the next one. Next one will be our quadratic polynomials. Okay, quadratic polynomials or polynomial. So let us write any example. First of all, let us write any example. Let us write 4x square plus 5x minus 7. This will be one of the examples. Let us write one more example with y, like y square minus 2y minus 5. So you will notice that a quadratic polynomial will not have more than 3 terms. The maximum number of terms is 3 in a quadratic polynomial. Okay, so you can write a quadratic polynomial in one variable will have 3 terms at most, means maximum 3 terms. It will have maximum number of terms as 3. Okay, and the general form, what will be the general form? General form will be like this: ax square plus bx plus c. Okay, this is the general form of quadratic polynomial, where a is not equal to 0, because if you make a equal to 0, then it will not be a quadratic polynomial, it will reduce to a linear polynomial. So this is important, where a is not equal to 0 and a, b, c are constants. This you can write in variable y also: ay square plus by plus c, variable y. So a quadratic polynomial will have at most 3 terms, and the general form is ax square plus bx plus c for variable x, and ay square plus by plus c for variable y, where a is not equal to 0 and a, b and c are constants. Okay, so likewise we will write about cubic polynomials. Okay, we will understand the general form of a cubic polynomial. Okay, so the general form of cubic polynomial, first let us write one cubic polynomial. If you write 5x cube, this will also be a cubic polynomial. If you write 7x cube plus 10, it will also be a cubic polynomial. If you write 10x cube plus 7x square minus 9, it will also be a cubic polynomial. And if you write 15x cube minus 9x square plus 2x minus 15, this will also be a cubic polynomial. But you cannot write more than these 4 terms. So a cubic polynomial will have at most 4 terms. A cubic polynomial will have at most 4 terms. Okay, and the general form will be like this: ax cube plus bx square plus cx plus d. Likewise, a quadratic polynomial general form will be ax square plus bx plus c. Here it will be ax cube plus bx square plus cx plus d, and the condition is a is not equal to 0, because if you make a equal to 0, then it will reduce to a quadratic polynomial. Okay, and a, b, c and d are constants. Okay, you can write in variable y also similarly: ay cube plus by square plus cy plus d. This one be with variable y. variable y. So this is the general form. So far we have studied linear polynomial general form ax plus b, okay, quadratic polynomial of general form ax square plus bx plus c, and cubic polynomials general form ax cube plus bx square plus cx plus d. Now let us write the general expression of a polynomial having degree n. Okay, a polynomial of degree n, okay, in one variable. Let us suppose in one variable x. So its general form will be like this: an xn plus an minus 1 xn minus 1 plus an minus 2 xn minus 2. It will be like this, plus a1 x plus an. Okay, we are not going to write x0, this is hidden, x to the power 0. Okay, so 0 1 2 3 dot up to n, where all the a0 a1 dot an are constants and an is not equal to 0. Like same way, if this you will make 0, then this polynomial will reduce to n minus 1 degree. Okay, so this will be the general form of a polynomial having degree n. Okay, this is the general expression for any natural number n. For natural number n. Okay, now let us understand the types of polynomials according to number of terms. Okay, we have discussed types of polynomials according to degrees, like linear, quadratic, cubic and biquadratic. Now let us understand types of polynomials according to number of terms. So first one will come monomial. Okay, so what is this monomial? The monomial is a polynomial having one non-zero term. A polynomial having one non-zero term is called a monomial. So this monomial will have only one non-zero term. You can write this one as one. It will not create confusion. Okay, so what will be the examples? Examples will be like this: 5x, okay, or 15y, 10xy. All the this is examples of monomial having terms only one terms. There it is one term, it is having one term, it is, so all of these are examples of monomials. These are all monomials. Mono means one. The meaning of mono is one. Okay, and mials comes from polynomials. So second one is binomial. Okay, as the name suggests, binomial is a polynomial having two non-zero terms. A polynomial having two non-zero terms is called a binomial. So this binomial will have two non-zero terms. So the examples will be like this: 10 plus 19x, or 12x minus y, having two terms, two non-zero terms. So these are all examples of binomials. So binomial means two. Okay. Now the third one is monomial, binomial and trinomial. Trinomial. So the trinomial will be a polynomial having three non-zero terms. A polynomial having three non-zero terms. Three non-zero terms. It's called a trinomial. It's called a trinomial. Okay. The examples you can write like 10x square plus 5x plus 3, 5y square minus 9y plus 17. So all of these will be trinomials. Trinomials means having three non-zero terms, and tri means 3. Okay. So monomial, binomial and trinomial according to the number of terms. Now let us understand all these things with one example. So the question is like this: classify the following as linear, quadratic and cubic polynomials. We have 7 questions. So we will solve it. Let us write the solution. First one is x square plus x. So this will be a quadratic polynomial. Quadratic. Okay. Why quadratic? Because the degree is 2. Degree is 2. Okay. Second one will be 7x cube. 7x cube. It will be a cubic polynomial. Cubic polynomial. Because the degree is 3. Cubic polynomial. Degree is the highest power. Okay. Third one is y plus y square plus 4. Y plus y square plus 4. So it will be quadratic polynomial again. Quadratic. Okay. Fourth one is 1 plus x. 1 plus x. It will be a linear polynomial. Linear. Having only 1 degree. Fifth one is x minus x cube. X minus x cube. This will be a cubic polynomial. Cubic polynomial. Having degree 3. 3. Now sixth one is 2 minus y square. 2 minus y square. This will be a quadratic polynomial. Quadratic. Having degree 2. Now seventh one is 5t. This one will be a linear polynomial. Linear polynomial. Okay. So now let us solve some more questions to cover all these topics. Okay. So I have taken this question: which of the following expressions are polynomials? Write the degree also. So we have to find out that which of the expressions are polynomials, and if polynomials, then we have to write the degree also. So let us solve it one by one. Solution of 1. First expression is x to the power 5 minus 2x cube plus x plus 7. So the criteria of having a polynomial is, in the exponents we must have whole number or non-negative integers. Okay. So we can clearly see that x to the power 5 and 2x cube and plus x. So it is a polynomial. It is a polynomial. It is a polynomial, and we have to write the degree also. Polynomial of degree 5. Its degree is 5. Okay, the highest power. So now let's do second one. Y cube minus root 3y. So it is also a polynomial because the exponents of y are here 3 and here 1. So it is a polynomial of degree 3. The highest power is 3. Okay. Third one is x to the power 108 minus 1. So this is also a polynomial because in the powers we have whole numbers or non-negative integers. A polynomial of degree 108. The highest power is 108. Okay. Fourth one is cubic root of x minus 27. Now this is not a polynomial because you can write this as x to the power 1 by 3 minus 27. So this is not a whole number. So this will not be a polynomial. If it is not a polynomial, then no need to write the degree or no degree at all. So question 5, x to the power minus 2 plus 2 x to the power minus 1 plus 3. Again this will be not a polynomial. Because the powers are in negatives. Okay, so powers are not whole number or non-negative integer, so not a polynomial. Now sixth question, minus 3 by 5. It will be a polynomial. Of degree 0. A polynomial of degree 0, because you can write here x to the power 0. Okay, you can write like this. So this is a polynomial of degree 0. Now seventh one. What is the seventh one? Cubic root of 2 y square minus 8. So this will be a polynomial. Whatever be the coefficient, but the power is non-zero, non-negative and whole number. So it will be a polynomial of degree 2. Okay. Now eighth question. What is the eighth question? 4t square plus 1 by 60 plus 2 root 3. 4t square plus 1 by 60 plus 2 root 3. So this will be a polynomial. Of degree 2. The highest power is 2. A polynomial of degree 2 or quadratic polynomial, you can say. Now next question, ninth one. Z plus 5 by z plus 1. Z plus 5 by z plus 1. You can write this like z plus 5 z power minus 1 plus 1. So clearly this one, not a whole number. So this will not a polynomial. Okay. Now 10th one, 0. Okay, 0. So 0 will be a polynomial, and this is called a zero polynomial. And its degree is not defined. It is a polynomial. It is called a zero polynomial and degree is not defined. Likewise, when I told you this minus 3 by 5, this is a constant polynomial, but its degree is 0. But here 0 is a zero polynomial and degree is not defined. Okay, so let's move forward. So I have taken these two questions. First one is, give an example of first a binomial of degree 27, second a monomial of degree 16, a trinomial of degree 3. This is first question. Second one is, write coefficient of x cube in this expression, coefficient of x in this expression, coefficient of x square here, coefficient of x square here. Okay, so we will solve it one by one, and this question will complete your concept of binomial, monomial, trinomial, and coefficients also. The concept of degree I have made you understand in the previous examples. So let us solve it. First one is, we have to write an example of a binomial of degree 27. So two things are here. A binomial. What is a binomial? A binomial is a polynomial having two terms. So the number of terms will be 2. So, and having degree 27. So you can write like this: x to the power 27 plus, you can write anything, plus 52. So this will be a binomial, two terms, binomial of degree 27. Okay. Second one is a monomial of degree 16. A monomial of degree 16. So we have to write a monomial, means only one term will be there, and having degree 16. So let us write it in variable y to the power 16. Okay, done. This is a monomial having degree 16. Third one is trinomial. We have to write a trinomial of degree 3. So let us write in variable z, a trinomial of degree 3. So 10z cube, this will be having degree 3, plus 5z square minus 7z. So this is clearly a trinomial having 3 terms and degree 3. So a trinomial of degree 3. Okay. So this is done. Now second question, solution. Question 2, solution. This one was question 1. Now question 2. First one, write the coefficient of x cube in this expression. Okay, what is the expression? 2x plus x square minus 5x cube plus x4, and we have to write the coefficient of x cube. So here you can directly write that coefficient of x cube is equal to minus 5. See here, it is minus 5. X cube coefficient is minus 5. Okay. Second one is coefficient of x in root 3 plus 2x, root 3 plus 2x minus 4x square. This is the expression, and we have to write the coefficient of x. Coefficient of x is equal to, this one will be the coefficient of x, 2. Okay. So third expression is pi by 3x square, pi by 3x square plus 7x minus 3, and we have to write the coefficient of x square. Yes, x square. So this will be pi by 3. Okay. Fourth one is 3x minus 5. This is the expression, and we have to write the coefficient of x square. Okay. Coefficient of x square is equal to, so here there is no term having x square, so it will be 0. Okay. So now I hope that each and every concepts are clear with examples I have shown. I have tried my best to make you understand. In this lecture, we have understood the types of polynomials according to their degrees and according to their number of terms. Okay, and linear polynomials, binomial, like linear polynomials, quadratic, cubic, and biquadratic, according to the degrees, and according to the number of terms, they were monomials, binomials, trinomials. Okay, like this, and we try to understand these concepts with lots of examples. I have done so many examples, so many questions. So I hope these concepts are now very much clear, and since these are the building blocks of this chapter, so you need to do it very well, and I have tried my best to do it well. So from the next lecture we will move on to zeros of the polynomial. That is also a very interesting topic. So I hope you like my videos, and video If the videos are good, you are liking, then please like, share and subscribe my channel. Thank you very much.